Since the dawn of humanity, people have been wondering what space looks like. We now have technologies our ancestors couldn't even imagine. And we've come such a long way and peered into cosmic depths only to find out we'll never know for sure what the cosmos really looks like. When NASA posted this stunning image of the interstellar Lagoon Nebula made by Hubble, it went viral just 24 hours later. But the way the nebula is shown in the image isn't 100% accurate. And it's not just this image. All other images of colorful nebulae, star systems, and galaxies look different in reality. So how would we see nebulae, stars, planets, galaxies, and black holes up close? And why do scientists modify space images for us? NASA has a collection of images that show even the smallest details of celestial objects. And all this started with this simple black and white image. It was taken from the White Sands rocket back in 1946 at an altitude of only 105 kilometers. It was shot using a 35mm motion picture camera. The camera snapped a frame every second and a half, starting at liftoff. After a few minutes of flight, the rocket hit the ground and the camera crashed. But the recording placed in a steel cassette wasn't damaged. Since then, technology has come a long way. Space is imaged with the most advanced digital cameras. But the images are still shot in black and white. So where do all the amazing colors come from? It's not an easy task to show the universe as it is. Largely because of the imperfections of our eyes. We can only distinguish a fraction of the wide electromagnetic spectrum, and almost every image of space starts out in black and white. Then these images undergo the coloration process. Modern telescopes come to the aid of our perception of color. Take, for example, the famous Hubble Space Telescope. During its 32 years in orbit, it's taken many iconic images. The Wide Field Camera 3 is considered the most advanced of its several cameras. It allows the telescope to see everything, not only in visible light, but also in ultraviolet and infrared light, undetectable by human eyes. Shooting begins by focusing the telescope to clearly capture a very distant object. The camera is then triggered at the right time to take images in short, medium, and long wavelengths. Each frame takes on average about 1,000 seconds to create. HST also orbits the Earth at about 27 kilometers per hour, so it gets the right images after multiple revolutions around the planet. And each image for each wavelength is then assigned a different color, depending on its position on the color spectrum. Scientists call this process broadband filtering. Because of the high speed of the telescope, the enormous distance to celestial objects, radiation, dust clusters, and lack of light, these frames turn out somewhat fuzzy. So they have to be modified using special photo editing programs to remove cosmic rays, satellite trails, and other interference. Scientists then merge different frames into one to get the final version. That's how initially gray space images turn into multicolored. This bright mosaic of the Crab Nebula is assembled from 24 individual Hubble exposures taken by the wide-angle and planetary camera. The colors in the image indicate various elements that were ejected using supernova explosions and other cosmic catastrophes. But does the image show how the nebula looks in reality? The colors of the various elements of the nebula are actually somewhat different. But the real colors are in the wave spectrum invisible to our eyes. So without processing, we would only see a gray haze. And the Lagoon Nebula would also be completely unremarkable. But this doesn't mean the images are purely scientists' imagination. They only shift the telescope data in the invisible spectrum as close as possible to the frequencies we can see. The colors may differ depending on which wavelength the telescope uses. If you Google the Cat's Eye Nebula, you'll see many versions of it in different colors. Here, the nebula appears in green, and here it's shown in yellow or red. And this composite image uses data from two large NASA observatories. The X-ray radiation is shown in blue, and the ultraviolet radiation is shown in red and yellow. If the basic elements of the chemical composition of an object are known, this is also taken into account during the image coloration process. If scientists spot a supernova through a telescope, they often see clouds of gases expelled after the explosion. And because all gases absorb different wavelengths of light, it's important to assign proper colors to them. This is how Hubble's iconic Pillars of Creation image was taken. It shows the Eagle Nebula 6,500 light years away from Earth. You can see stunning multicolored columns of gas and dust clouds illuminated by the intense ultraviolet light from young stars. Each element is represented by a different color, corresponding to Hubble's palette. Sulfur is shown in red, hydrogen in green, and oxygen in blue. But can we say these are the actual colors of those elements? Not really, and here's why. Each one of those elements has a unique set of absorption and emission lines, and the pattern of lines is called a spectral signature. The absorption and emission spectra of each element are opposite of each other. When light passes through a gas, atoms and molecules in the gas absorb certain colors of that light. This is called the absorption spectra, which is a rainbow with dark absorption lines. At the same time, the gas can glow, giving off specific colors to form an emission spectrum with bright lines called emission lines. Oxygen gives off a green and red hue in the spectrum. Sulfur and hydrogen are also red. So, to distinguish sulfur from hydrogen, the color of hydrogen is shifted towards the green spectrum, and oxygen is shifted toward the blue spectrum. So the famous pillars may not look like that in reality. Here's another image of the Pillars of Creation made by Hubble in infrared light. Nebulae captured by telescopes certainly turn out cool. But what about images of other celestial bodies? Recently, the world was stunned by the first real image of the supermassive black hole Sagittarius A star. The image was taken by 8 radio telescopes scattered around the world. Astronomers say it's very difficult to take images of such a huge monster. Its accretion disk is spinning incredibly fast, and to make a clear image of the black hole, scientists processed millions of different images on supercomputers. As a result, they received the image showing a bright accretion disk of glowing gases with a black abyss in the middle. In the past, artists drew the black hole based on scientific data, and they had nearly the same result. But the form of black holes remains unclear. Why does the sci-fi movie Interstellar portray the black hole Gargantua like this, and not the way scientists did? Besides, NASA also has images of black holes of a similar form. According to experts, this is all because of different angles. If you look at these monsters perpendicular to the accretion disk, they'll look like those captured by 8 radio telescopes. But if you look at them at an angle of 90 degrees, you'll get a different view. The light behind a black hole will be refracted over its event horizon and break through to its front. In this case, we'll see the back and front sides of a black hole's disk simultaneously. There would be a kind of circular halo and a strip of light inside of it. However, telescopes aren't perfect, and they cannot see everything in the universe. The surface of distant exoplanets is usually hidden behind a dense veil of gases. So even when you see that some sources illustrate distant world surfaces, these are mostly visualizations made by artists. However, their interpretations are also based on scientific data. Take the image of the exoplanet TRAPPIST-1d as an example. It orbits very close to its star, so the star will look like a giant in the exoplanet sky. But the star is dim, and an artist took this data into account when creating the image. Our galaxy is also visualized based on existing data. But because we're located inside of it, we can't see the whole picture. Scientists know that the Milky Way is shaped like a disk with a thickening or bulge in the middle. The disk is more than 100,000 light-years in diameter. Spiral arms filled with billions of bright stars diverge from its center. This is how people usually imagine the Milky Way. This image was created by an artist using data from the Spitzer Space Telescope. But recent discoveries may change the way we visualize our galaxy. Polish researchers suggested the idea that the disk of the Milky Way isn't flat, but has an S-shaped curvature. This means our galaxy is twisted upward at one end and downward at the other end. Another study found a break in one of our galaxy's arms, piercing the spiral like a splinter. And it's quite large. The structure has a length of about 3,000 light-years. Scientists still don't know what celestial force did this. What we do know is our view of the Milky Way will change over time, probably until the day we see our galaxy from space. Do you think images made by telescopes give us a realistic view of the universe? Tell us in the comments. Leave a like if you enjoyed watching the video, and to keep up to date with the most intriguing space discoveries, be sure to subscribe to the channel. Thanks for watching.